In this chapter, we're looking at how to perform hypothesis tests for hypothesis about population parameters. Specifically, in this problem, we're looking at population proportion. So our hypothesis we want to test is whether the proportion is equal to 0.6 versus whether the proportion is greater than 0.6. We're going to perform this test using a p-value approach, and we're going to use StatCrunch to calculate the p-value. One reminder, for us to be able to use the normal model to approximate probabilities for proportions, we need that n times p times 1 minus p be greater than or equal to 10. Where p is the true proportion. In this case, the p0 is the p from the null hypothesis. So if we take our sample size 200 times 0.6 times 1 minus 0.6, that actually equals 24, which is greater than 10. And so the answer is yes. So you want to make sure that you actually calculate that on a calculator on these problems. Otherwise, you may run into a problem where it does not work. So now we want to derive the p-value for this test. To do that, we're going to use basically the same package we did for confidence intervals in the last chapter. Since it's a proportion, we're going to use proportion stats, one sample, and again we have summary. And so our number of successes would be x, 125. The number of observations would be 200. We're now performing a confidence interval. We need to make this look like we're now performing a hypothesis test, and we need to make this look like our hypothesis. So we want the null to be 0.6, and the alternative is greater. Once we've done that, then we can press compute. And here at the end, this is our p-value. So our p-value here would be 0.235. And then remember, when we are performing a test, we want to compare this p-value with the alpha level of significance. In this case, the p-value is larger than alpha. Anytime that it's larger than alpha, that is not sufficient evidence for us to reject, and so we do not reject. We only reject when the p-value is less than the alpha level here.